Okay, today we're going to talk about solving radical equations. First of all, what is a radical equation? Here you see two equations and both of them contain a radical, but this one is not a radical equation. This is an ordinary linear equation. This one is a radical equation. So what's the definition of a radical equation? A radical equation is one in which at least one variable is under a radical sign. So in the case of this equation here, the variable x is not a radicand, that is not under a radical sign. You only have a radical 5, and radical 5 is just a number, so this is an ordinary linear equation. But in this other one, you have the x, which is your variable or your unknown, stuck under the radical sign. So this is a radical equation. So how do we solve this one? You just isolate x. So you move the 3 radical 5 to the other side. You get 2x equals 11 plus 3 radical 5. Then you divide both sides by 2. You get x equals 11 plus 3 radical 5 over 2. And that's it. For this other one, which is a radical equation, the way you solve it is you first isolate your radical expression. So I move this 5 to the other side. I get x plus 1, radical x plus 1 equals 7 minus 5, which is 2. So that I have my radical expression isolated. Now that my radical expression is isolated, in order to get rid of that radical, I raise both sides to power of 2. Why to power of 2? Because this is a square root. It's a radical of index 2. If it were a radical of index 3, if it were a cube root, I would raise both sides to power of 3. If it were the fourth root, I would raise both sides to power of 4. But in this case, since it's a square root, in order to get rid of the radical sign, I raise both sides to power of 2. So this side raised to power of 2, and this other side also raised to power of 2. Radical x plus 1 to power of 2 is just x plus 1. And 2 to power of 2 is 4, and now I have a linear equation to solve. This implies that x is 3. Okay, now let's check our answer to make sure that it works. If I plug in 3, 4x into the original equation, I get radical 3 plus 1 plus 5. That is radical 4 plus 5, which is 2 plus 5, which is 7. So yes, it works. This checking step is actually a crucial step when you're solving a radical equation, because it's possible when you're solving a radical equation, it is possible that you are doing all the steps correctly, you're doing all the algebra correctly, and in spite of that, at the end, you come up with a bad solution, an extraneous solution, which is even not as this is not even a solution. So the reason for that is this process of raising to power of 2. This process of raising to power of 2 can generate some bad solutions. So this checking step when you are solving a radical equation is a crucial step. It's necessary to check your answer and make sure that it works in the original equation. Make sure that it satisfies the original equation. Why? Because the process of solving a radical equation can generate extraneous or bad solutions. Okay, let me give you an example of an equation that generates some extraneous solutions. X plus radical x minus 4 equals 10. Okay, first step, isolate your radical expression. So moving x to the other side, I get x minus 4 under the radical sign equals 10 minus x. Now that I have my radical expression isolated, I raise both sides to power of 2. This gives me x minus 4 equals 100 minus 20x plus x squared. Okay, if I write this in a standard form, I have x squared minus 21x plus 104 equals 0. So if you solve this equation, you get two solutions. X equals 8 and x equals 13. It's actually negative 8 and negative 13, so that their product is 104 and their sum is negative 21. So this is x minus 8 times x minus 13 equals 0, which means that x is either 8 or 13. Now let's check the answers. If I plug in 8, so let me correct this, it's 100 minus 20x plus x squared. So now let's check the answers. If I plug in 8 into the original equation, I get 8 plus radical 8 minus 4, that is 8 plus radical 4, that is 8 plus 2, which is 10. So that's okay. This one is accepted. Now let's check 13. If I plug in 13 into the original equation, I get 13 plus radical 13 minus 4, that gives me 13 plus radical 9, that is 13 plus 3, which is 16, and 16 is not equal 10, so this one does not work. This means that this other solution is an extraneous solution and it must be rejected. The only solution to this radical equation is x equals 8. Okay, let's look at another example. Radical 2x plus 10 minus x equals 1. Moving x to the other side, I get radical 2x plus 10 equals 1 plus x. I raise both sides to the power of 2. This gives me 2x plus 10 on the left side and x squared plus 2x plus 1 on the right. You can see that the 2x cancels the 2x. This implies that x squared minus 9, moving 10 to the left, to the right, equals 0. This implies that x is either 3 or negative 3. Okay, now let's check the answers. If I plug in 3 into the original equation, I get 6 plus 10 minus 3, that is radical 16 minus 3, which is 4 minus 3, which is 1. Okay, good. The equation is satisfied. What about negative 3? If I plug in negative 3 there, I get radical negative 6 plus 10 minus 3 is a plus 3. That is radical 4 plus 3, that is 2 plus 3, that is 5, and 5 is not equal 1. This means this other solution is rejected. So 3 is accepted, negative 3 is rejected. So the only solution here is x equals 3. So as you can see, it is crucial, it is very, very important for you to check your solutions if you're solving a radical equation, because it's very likely to get extraneous solutions. Another example, in this one we have two radical expressions. We have 3x minus 8 plus radical x equals 4. So what do you do if you have two radical expressions? So the process doesn't change. You isolate one of the radicals and you raise both sides to power of 2. And it's always a better idea if you are isolating the radical that has a bigger expression under it. So here I have 3x minus 8. Under this radical I have just x under this other one, so I isolate this radical because I have a bigger expression as the radicand. So 3x minus 8 equals 4 minus radical x. I isolated one of the radicals. Then I raise both sides to power of 2. This gives me 3x minus 8. On the other side, I get 16 minus 8 radical x plus radical x to power of 2, which is just x. Okay, as you can see, I still have a radical in here. So I need to repeat the procedure. That is, I need to isolate the radical expression and raise both sides to power of 2. So moving everything to one side and keeping just the radical on the other side, I get 2x, moving this x to the left, minus 24 equals minus 8 radical x. Okay, at this point I can see that it's possible to factor out 1, 2 from this expression, and on the other side I have minus 8 radical x. So let's simplify so that we can work with smaller numbers. If I divide both sides by 2, I get x minus 12 equals minus 4 radical x. Okay, now that I have my radical isolated, I raise both sides to power of 2. This gives me x squared minus 24x plus 144. This other side to power of 2, negative 4 to power of 2 is 16, and radical x to power of 2 is just x. So this becomes x squared minus 40x plus 144 equals 0. And if you solve this quadratic equation, you get two answers. You get x equals 4 and x equals 36. Again, you have to check your solutions. So if you let's check. If you plug in 4 into the original equation, you get radical 12 minus 8. 12 minus 8 is just 4, yeah? So radical 4 plus radical 4, that is 2 plus 2, which is 4. So this one is accepted. If you plug in 36 into the original equation, you get radical 36 times 3 is 108. 108 minus 8 is just 100, plus radical 36. This is 10 plus 6, which is 16. And 16 is not equal 4. So you see the other solution does not satisfy the equation, so it is rejected. So in this case, the only solution is x equals 4. One last example, and this one is a little different because we have a cube root. 3x plus 1 equals 4. If you have a cube root, you have to isolate your radical expression, and in this case, because it's a cube root, you raise both sides to power of 3. So raise this to power of 3 and this side to power of 3. This gives you 3x plus 1 because radical index 3 of 3x plus 1 to power of 3 is just 3x plus 1. And this other side, 4 to power of 3 is 64. And then you have a linear equation to solve. So 3x is equal 63, which implies that x is 21. And you check your answer. If I plug in 21 here, I get 63. 63 plus 1 is 64. Radical index 3 of 64 is 4, so the equation works. So the only difference was because I have a cube root, I raise both sides to power of 3. And that's it for solving radical equations.